Welcome to Hope Academy. My name is Mr. O, and today I'm going to be covering numbers 10 through 12, the very last questions in the last exam, exam 5 on the ACT online website. That being stated, if you want to access the exam and practice on it yourself, the link is below. But these are the last questions. Feel free to look at the playlist to see the other or prior questions that I have covered. But that being stated, I usually do these questions real quick first, and then I explain in depth how I was able to get to the answer. So I'm going to go ahead and get started. So for number 10. Okay, so they give it here. Area of the larger square, how many square inches is greater than smaller? Oh, so they're asking for the shape. Okay. Okay. So for number 10, my final answer is going to be J. And now, the way that I was able to get to the answer or solve this out, I could see a little bit of possible issues that come up or confusion that occurs that many people will make mistakes. So I'm going to also explain or anticipate the possible mistake you made in this question. So when you're doing this, the first thing you have to recognize is that I'm trying to get the area of the bigger square. So the total area of this bigger square right here is x plus c, because if you look right here, it's x plus c, and thus what I did right here, the x plus c times x plus c. And I also knew that I have to subtract the smaller circle so I could get the area of the shaded region. That's what we're going for. So x times x, which is x squared. But a lot of times when people do this, do solve this out, what happens is that they jump to the solution and think that it's just going to be x squared plus c squared minus x squared. And thus why the answer should, technically be f or c squared. But that is not actually the case for this question, because what you need to make sure to do in this question for number 10 is to not per se to expand. I think that's the right term, to expand. A lot of ways, some ways you could do is by box method, diamond method will work, foiling method will work, whichever method works for you. But that being stated, whenever you follow that procedure to do so, you have to remember x plus c is going to be x squared, and this is the box method duly note, I'm just using this, cx, and c squared. Thus, how I got this part right here, x squared plus 2cx plus c squared, and then minus x squared, and then I just combine like terms to get the final answer of J. And that concludes my explanation for number 10. But that being stated, now I'm going to go ahead and continue to number 11, so I'm going to go ahead and get set up so you can see what I'm doing. Okay, so for number 11, there we go. Cubes with edges of side length at half, length of diagonal. Okay, I see. Okay, x root 2, so root 2 over 2. So that triangle is going to be half, but x root 2, okay. Now you find the length of this. So it'll be 1/4 plus 2/4, which is 3/4 through 3 over 2. Okay, so for number 11, my final answer is going to actually be E. Okay, and so now I'm going to go ahead and actually explain this, and I'm going to explain it in this space right here. So the idea is that there's this cube that's half inches all around, and that there's some sort of diagonal that exists that's going through this cube like this, okay? And that's my question mark. And so the idea behind this question is to sort of be able to visualize this question, because it is hard to visualize it at first. But the idea is that if I have half here, I need to find, in order to find this hypotenuse of this right triangle that's floating right here, in order to find this hypotenuse right here, and I'm actually going to use a different color so it will be easier for us to follow this question. But in order to be able to find this length right here, I need this length right here, which is, I know it's half, and I also need this length right here, which I do not know the length of yet, just for now. But that being stated, what I can do is that I can find this missing length right here by finding the triangle, this right triangle that's going to be part of the base. So right here, the base value right here, if I was to create another visual right here, is sort of like a base triangle, right triangle again, that's half by half. Okay, and to find the length of this part hypotenuse right here, you could either use two methods. You could use Pythagorean theorem, which will take longer. The a squared plus b squared equals to c squared method will take more time. Personally, for me, I knew right off I could use the special triangle rule. Okay, special triangles, okay? And it's not per se the 3, 4, 5 or the special triplet numbers per se. There's another property that exists where if I have two sides equal to each other like this x, I know right off my hypotenuse will be x root 2. So I knew right off will be half root 2 or aka square root 2 over 2. This I was able to solve out just knowing this property and it saved me time. And now that I have that fact that's square root 2 over 2 right here, now I can pull out the bigger triangle. And now I'm going to do it in orange. The bigger triangle, which is going to help me solve for the question that's asking for. That big question mark that was in the question. So it's half, and it says square root 2 over 2. Now I could use the Pythagorean theorem, which takes more time, but that's the only way I could end up solving it out. And so when I did the Pythagorean theorem right here, and now I'm going to grab another color, what happened? Pythagorean theorem, it became half squared plus square root 2 over 2 squared, which is going to be 1/4 plus, because square root 2 times square root 2 is just 2 over 4, which is 3 over 4. And remember, this is for c squared of the Pythagorean theorem, so I now need to take this value right here and square root the whole thing, which is going to be square root 3 over 2, which is how I got my final answer of E. And that concludes my explanation for number 11. Now to continue on to the very last question for the whole ACT exam. Okay, so for number 12, which is equal to sine, negative sine, whatever is it defined. Okay, what's going to be sine theta over times 1 over sine negative theta, which is negative sine, so negative 1. Okay, so for number 12, my final answer is going to be F. So for this specific question, there's the two things you need to remember. You need to remember one little rule that does exist, which is that cosecant of theta will equal to 1 over sine theta, which is very useful to know. But you need to also remember the property that sine of your negative theta will equal to negative sine theta. Okay, that's what they're testing. This is sort of a trigonometry idea or identities or rules that you need to abide or understand. But that being stated, the way that I remember this usually is that cosine, whenever there's a negative inside for cosine, it does not change. Cosine negative theta will equal to just cosine theta. But for sine, the sign actually changes. For sine S-I-N-E, the sine S-I-G-N will change, okay? And so what happened was that for me, I automatically converted this cosecant negative theta to 1 over sine negative theta. I understood right off this would become negative sine theta. So sine over negative sine would end up becoming negative 1. And thus how for number 12, my final answer is going to be F. And that concludes my explanations for the whole ACT online exam. Thank you so much for watching through these videos. I will continue on to new projects and so on, so feel free to suggest if there are other concepts and whatever not by commenting below, and I read through all the comments, so feel free to do so. But that being stated, please do subscribe to our YouTube channel, like our Facebook page, follow us on Twitter so that we could continue through this journey. I hope you have a wonderful day.